So we do have a servo here. This is a servo motor, and this one's unusual in the fact that servo motors require a driver, and as does the stepper. Stepper has a driver that puts out steps. The driver for a servo motor does not put out steps. It puts out current. All right, it's not stepped, and it is putting out. This is actually a three-phase motor. It runs on DC, but the driver turns the DC into AC, 3 sets of coils to make the motor turn. Okay, and the servo motor, the driver controls the current, which controls how much force the motor puts out. Unlike a stepper, that the current's always the same, on a servo, the current is proportional to the load on the motor. So we can get torque feedback from a servo motor very easily. And this particular one puts out a signal that's proportional to the motor current that the motor's pulling, which is equal to the load. So servo motors are also have to have commutation, meaning that you need some way to switch poles on and off. So they have an encoder in the motor to measure, to tell the controller where the rotor is. So that as it's turning the coils on and off, the encoder is telling the drive when to turn the coils on and off. And since you have an encoder, you also can get back feedback saying that the motor is in fact where it's supposed to be. Now, this particular type of motor does not have position feedback out of the motor. This is kind of semi-closed loop. In other words, the encoder is telling the drive where it's at. And so the drive always knows where it's at. But if it's not where it's supposed to be, all you get is a false signal. You don't get an encoder value back that says that where you really are. Okay, so this is a less expensive way of doing it. Other servos, they have an encoder on the motor, and they typically actually have two encoders. One encoder is for commutation of the motor, and the other encoder is for position. And so they have to bring all that wiring back to the driver, which is in a control cabinet. But servos can position, hold position and stuff. And there's also the issue that what people don't realize, there's something called servo lag, which is where the servo doesn't know, it has to have some error in order for it to be able to say, I'm not in position. If there was no error, you'd have nothing coming back. So that servo lag is something that you wind up doing tuning on the driver to get rid of servo lag. So that because when you put a load on the motor, in order for it to tell that it's got a load, the encoder has to go out of position. So the reality is the encoder has a whole lot more steps than the signal we send the motor. We send this motor 800 steps per revolution, but the encoder on it is like 40,000 steps. And that's so that when it's, I'm within 800, but I'm 50 steps away from 800, so I have to move a little bit. Okay, so there's one last kind of motor